All right, hello ladies and gentlemen. Today we will be doing a video on logarithms. I'm going to try to keep it as short and as simple as possible. So if you're wondering what the heck a logarithm is, basically it's an operation involving exponents and ways to solve different exponent equations. So yesterday we learned all about if the bases are the same, then we can assume the exponents are going to be equal to each other and we can solve. Now these are going to be circumstances that maybe it's not as simple as just setting the exponents the same, all right? So we have this really cool conversion factor up here, right? And it is very important. And in my classroom, it's hanging up on the wall. Otherwise, most of the time, you just have to memorize this. Now, I will say, for our purposes, it's going to be very convenient if we, sorry, I knew that was going to jump. If we go ahead and write these backwards. And you'll kind of see why, but I'm going to go ahead and write this as b to the x power equals y. And then over here, same thing, I'm going to write log base b of y equals x. Now the reason I find this to be very helpful is because in our examples it's going to be kind of written in this format, so having it kind of flipped is nice. So what we're basically doing is switching between exponential and logarithmic form. If you remember, we did something very similar when we did exponents, and we said that if you have x to the 3/2 power, you can rewrite that as, the index is 2 and the exponent is 3. That's what we're doing here. We're switching between exponential form to logarithmic form. So using this conversion factor, I'll have a 2 to the 3rd equals 8. Look at how it converts to logarithmic form. And we're going to say that we have log. Remember, the b was 2, so I'm going to have a little 2. Then I have the y, so the y was 8, equals x. Well, my x was 3, so equals 3. So for each of these, we're going to real quick do that and just say that I have log, my 2 was my b value, the 16 comes on the other side, and the 4 goes to the other side. Now here's a quick way that I always think of this and a way to kind of memorize this. Down here you'll see, how do you pronounce a logarithmic equation? Let's say that we wanted to pronounce this example right here. We would read this logarithmic equation as log base 2 of 16 is 4. The key here is it says base 2. When it comes to exponents, this 2 is your base. It's the same thing with logarithms. So when I look at this, if my base is 2, I'm going to have log base 2. Okay? That 2 will forever be my base. And then the x and the y end up just switching sides. So this 1 comes over here, and the 0 goes to the other side. So once you kind of figure out that conversion, it is a very quick process. So again, saying here's my base is 2, and then switch the 1/2 and the -1, switch them on sides, and you're done. So if we go ahead down to the next section, it's basically asking us to do the same thing, but the other way around. And again, understanding that it says log base 2 is very helpful. So this one reads log base 3 of 81 is 4. So if I go to convert this, my base of my exponent should be 3, and then the 81 and the 4 switch sides, so the 4 becomes my exponent and the 81 goes to the other side. Now what's really cool about this conversion aspect is we don't quite know what log base 3 of 81 equals 4 actually means. But we do recognize that 3 to the 4th equals 81. That is a true statement, and so we know that we're on the right track. If I got some weird answer like maybe 4 to the 3rd equals 81, that's not true, so we probably messed up somewhere. Okay? So if you double check it and say, is 3 to the 4th power 81? Yes, then you're golden. If I go ahead and convert the next one, again, read it and say log base 3, so my base is 3, switch the 0 and 1, and again, 3 to the 0 power equals 1 is a true statement. And then the last one, my base is 3, sorry, I forgot to bring the -2 over, equals 1 over 9. Is this a true statement? Does 3 to the -2 equal 1 over 9? Yes, because 3 squared equals 9, and then that negative tells you to move it to the bottom. So all very true statements. Now one of the really cool things is that your calculators can actually do a log. There is a log button on your calculator. The only sad part is that it only does common log. Okay? Your calculator will only do common log. Common log basically says when the base is 10. And if you think about it, it's common because, like, think of our metric system as base 10, things like that. So in common logs, it always has to be a base 10. So these base 3s will not be able to be plugged into a calculator. But something that is a base 10 would be the examples down below. Now you might be looking at these examples and saying, these aren't base 10. I don't see a little 10 on any of these. Think of them like a square root. You know when I say what's the square root of 4, we said, oh, well, what's the index? What's the number right there? Technically it's a 2. They just don't always write it. It's the same thing with logs. If they are not assigning it a value, like this one assigned it a value of 3, right? If they are not assigning it a value, then you can safely assume that it's going to be a 10. So all of these don't have values, so we're going to assume they're 10. Now these ones say evaluate directly with the calculator. Don't do anything, any conversions or anything like that. Simply plug it into a calculator. So if I pull up my calculator, I'll show you where the log button is. It's right here. So all you have to do is hit log. Again, it assumes that it's base 10. You don't have to type in anything. The first example in our notes is a log base 10 of 16. So I'm going to go ahead and type in 16 and hit enter. That's the value. So very similar to the examples up here where it tells me the value, this one's going to be equal to 1.204-ish, right? So you can take the time and try to convert those other ones. I will say that the next one should give you a 3, a -2, and a 1.68. So if you try those on your own calculator, all calculators have the log button. Try those and see if you get those same numbers, and if you do, you're on the right track. Now, the backside is really the fun part. This is what we're working towards. This is the good stuff. All right? Now, I don't know where's my number 2. Oh, there's number 2. Okay, perfect. So I'm going to do the first 2 examples with you, and then you can practice the ones down below and see if you get the same answer as I. Now, the directions say to evaluate. Evaluate usually means solve for x. This problem doesn't even have an x, so the directions come right out and say set the logarithmic expression equal to x, silly me, equal to x. So you could, in theory, go through all of these and go ahead and set them equal to x. That way, we actually have something that we can convert. Then it says rewrite in exponential form. Okay, so what we're going to do is say, okay, my base is 5. We just did this on the front. My base is 5. My x and my 25 switch sides. Now what this is what we learned yesterday. So basically, we want to say 5 to what power equals 25? Well, 5 squared equals 25, so x equals 2. Another option that you could have looked at this as is you could have left it as a 5 to the x power and said, how do I rewrite 25 so that it has a base of 5? Well, 25 is the same thing as 5 squared, and now you can clearly see that x equals 2. So either way would have been fine for this problem, just kind of showing you that. If I go ahead on to number 2, okay, number 2, again, convert it. My base is 4, so I'm going to have a base of 4. My exponent will become x equals 2. Now again, think, how can I rewrite that so that they have the same base, right? And I'm going to put a 1 in there because my base is 2, exponent of 1. What if I rewrite that 4? Let's say I rewrite 4 to become 2 squared. The x is still there, and then on the other side you have 2 to the first power. Now they have the same base, and you can see why we had to do yesterday's notes before today. It's very important that you understand that if the bases are the same, then the exponents will be equal, and therefore you get x equals 1/2. And again, don't be afraid to get those 1/2s. It's perfectly fine. Now some of these, with the time remaining, I'll point out some key factors and let you guys practice these last couple. But some really nice ones that I'd like you to pay close attention to are number 5. Number 5 is a tricky one. And then also possibly number 7. The other ones are the same idea. If you go ahead and convert these, 7 to the x power equals 49. Well, then you're asking yourself what power? Same thing over here. The nice thing about this one is when you get 3 to the x power equals 1, you run into that conflict that we had yesterday with the 1. And if you recall, we could rewrite that as 3 to the 0 power, and therefore x equals 0. And then same thing with this last one, which I forgot to make these equal to 0. With this last one, if I set this up, I'll get 25 to the x power equals 5. You're going to need to change the 25 and not the 5. So this one would become 5 squared, right? That's the 25. With the x, because the x is still there, equals 5 to the first, and you'll get 2x equals 1, very similar to the top. So I'll let you kind of go through and finish out these ones on your own without giving you any work and simply telling you the answers. I would like you to do the work, but I'm giving you the answers so that way you know if you got them right or wrong. This one would be x equals 1/2. This one over here, you should get x equals -5, x equals 4, and x equals 2. So for these examples, I would like you to still try them by yourself and see how you do. 8's the only one, the other one that I imagine there could be some issues with if you're trying these at home by yourself. When you convert that, you're going to get 2 to the x power equals 1 over 32. Remember that 1 over 32 is on the bottom of a fraction, so whatever answer you think of will have to be negative, right? Or sorry, not the answer itself will be negative, but the exponent will be negative. So if I think of this as 2 to the 5th power, right, because 2 to the 5th gives me 32, because it's on the bottom, my exponent's going to have to be negative, in which case now you have a 2 to the x power equals 2 to the -5th, and that's where you're going to get that x -5. So again, it really just windows down to what we learned yesterday once it's set up to one of these problems. Once you get it converted, it's just like a problem from yesterday. So if you did good yesterday, this should come as no problem, but it's really just that conversion factor. So I would strongly recommend that while you're doing your homework or while you're doing those practice problems, have these conversion factors next to you, because that's what you're working between. You're going from logarithmic to exponential, or eventually exponential to logarithmic, depending on what they require. And knowing that the base stays the base, and the x and the y switch sides. The x becomes the exponent and the y becomes the other side. So knowing that conversion should make it very easy. So hopefully that helps a little bit, and good luck with your practice problems.